Welcome back to SOFTEC 10 2025. Let's continue with our afternoon session with the fourth keynote entitled Enhancing Test Improvement Processes with AI. The speaker for this keynote, ladies and gentlemen, has almost 35 years experience in software testing and industry, and is currently Experimentus practice lead for process improvement. He has experience accredited TMMI-led lead assessor who has worked worldwide to help organizations improve their testing processes and attain certification. And without further ado, ladies and gentlemen, I'd like to invite Mr. Simon Frankish to the floor, please.
Thank you.
Here you are. Thank you.
Good afternoon, everybody. I came 28th in that quiz, so obviously not a very good quiz. I'm going to talk to you about enhancing test improvement processes with AI. We've heard a few different takes on AI, a few different uses for AI. My first love in work, at least for what it's worth, is test process improvement, particularly using TMMI. And I know there are a lot of people here who have used TMMI. I'll just introduce myself. As I said, around 35 years experience in the industry. I'll just share how I started in testing, actually, because listening to Professor Dhaliwal this morning talking about how testing's become a profession over the years. Back in 1990, I joined a large British organisation as a trainee COBOL programmer. So that's how long ago that was. I was trained in COBOL, and I sat there at lunch trying to work it out, and it's almost exactly 35 years to the day. I wrote a program which went live and promptly destroyed most of British Gas's systems. I'd done something terribly wrong. I was taken aside by a senior manager and told, in almost exactly these words, "You're not clever enough to be a programmer, you'll probably be okay as a tester." So that's how I got into testing. Fortunately, testing evolved. It's now a recognised profession in its own right, and I'm extremely happy about that. I am the head of process improvement at Experimentus. We work around the world. We've worked a lot in Malaysia. We have a relationship with the Malaysian Software Testing Board to help people here do that. In order to understand how I think you can use AI to help improve your test processes, we do need to look at the test maturity model integration, or TMMI, as we call it. Firstly, the 5 maturity levels. The first one is initial. Everybody gets initial. There's no assessment for initial. It's ad hoc. It's chaotic. You do testing, but you're not really got much structure around it. But things just happen. We then move on to managed. So at this point, we've got the important concept of testing being a set of managed processes which are separate from development, and that you retain those processes as you work through your testing. When we get into defined, we're now talking about a really fully integrated set of project lifecycle processes for testing. And testing starts up front, so we introduce things like reviews and static testing, etc. at that point. Level 4 is measured, and we talk a lot there about ensuring that people are taking the measures they need to take in order to control their testing and in order to ensure that their testing is well-founded. And they've got proper objectives, which they measure through quantitative quality goals. And finally, optimization. And I know there's at least one organisation in the room represented today that's got level 5. Your testing is fully defined, it's continually improving, and you're controlling the cost and effectiveness and efficiency of your testing in a really sensible way. We'll just run through the process areas very quickly. Within each process area, within each maturity level, there are process areas. The first one, level 2, has what we'd call the foundational process areas. So we've got test policy and strategy. The policy is why you do testing. The strategy is how you do testing. And that's at an organizational level. So we like to see definitions of those. We have test planning. I think you all know what test planning is. Very important aspect of testing. Test manager control is what, as test managers, test leads, testers, are you actually keeping an eye on while you're testing? What's being controlled, what's monitoring, and what are you reporting on, quite importantly. Test design and execution really speaks for itself. You're writing tests, you're running tests, you're recording results, you're raising defects. And test environments, obviously very foundational for testing. So how do you specify your test environments? How do you then implement your test environments, and how do you control and manage your test environments as time goes on? Level 3. So we add a few things here. Test organization is important. This is about testing being a profession now. So have you got job descriptions? Have you got career progression for testers? Do people understand what their roles are? Does the organization as a whole take the concept of testing as a profession seriously? And that's often complemented by the next one, which is the test training program. So what training are you doing for your testers? How are you helping them to progress? How are you helping the organization to progress through strategic training needs, for example? Test lifecycle and integration really talks about how testing is integrated into the wider development lifecycle. So what are you doing in order to make sure that testing is supporting the wider development lifecycle, and other people in that development lifecycle are supporting testing adequately and effectively? We introduced non-functional testing at level 3. So non-functional testing can be security, performance, usability, accessibility, whatever it may be. And what we really look for there is evidence that the same rigor that we saw at level 2 for functional testing is introduced for non-functional testing as well. So again, you're looking at good test planning, etc., for your non-functional testing. And finally, we've got peer reviews. So peer reviews is the static testing. How are you reviewing not only your work products, but probably more importantly, your test basis documentation? So how are you reviewing your requirements, your use stories, your epics, your use cases, etc.? And are testers involved in reviewing those and passing comments back? Level 4, we switch down now. There's only 3 process areas at each of level 4 and 5, as opposed to the 5 at levels 2 and 3. Test measurement is a discussion of what are you measuring at an organizational level in order to ensure that you can prove that your testing is efficient and effective as you're doing that. Product quality evaluation builds on monitoring control, so it looks at what you're measuring while you're testing and looks to use that information to make quantitative measures of product quality as you go through your testing life cycle. And finally, advanced reviews, as the name suggests, builds on peer reviews, but really what we're looking for here is evidence that reviews are used as an early indicator of quality when you're doing your testing. So if you're reviewing requirements, for example, and they're poor, and you're passing back a lot of comments and there's a lot of change, you might decide that you need to do more dynamic testing further down the line. So are you using reviews to measure quality and potentially then adapt your approach accordingly? At level 5, some really interesting things, and interestingly, we find people are often doing some of these when they're not doing some of the lower level, particularly defect prevention. So when you raise defects, are you selecting some of those defects for root cause analysis, and then putting measures in place to stop that root cause occurring in the future? Quality control is probably the single most difficult process area in TMMI. It's about using data to generate statistical methods for testing, which means your testing becomes basically more efficient. So can you use data to make stock test decisions based on historical data, based on extrapolations, etc.? And finally, test process optimization. As it sounds, you're continually reviewing your test processes, but you're also continually reviewing test tooling. The test tooling is included in there as well. And implementing new process, implementing new tooling, and making it work for you. So we took a step back and said, how can AI support each of those process areas? And I think when you look at it, it's more obvious in some areas than others. But obviously, you can use it in every area. We haven't seen all of these. So a lot of this is theoretical. We have seen some of these, but obviously we haven't seen all of this. Test policy and strategy. So use AI to analyze and align the policy and strategy documents with industry standards. So at the moment, that's a manual process. People will write policy, people will write a strategy. We help them do that. But you could easily see how you could run that through with AI and come up with some standardization based on the industry. Test planning. Important part of test planning is test estimation. So again, use AI to crunch the numbers, base it on previous releases, base it on previous knowledge, and come up with proper estimated efforts. I know from experience when we do TMMI assessments, test estimation is often a difficult subject for people, but we can make it better. Test management control is about reporting. So again, real-time dashboards, anomaly detection in your KPIs, a fairly obvious way you can look at implementing that, implementing AI to do that in order to help you improve at level 2. Test design and execution, probably the thing we see most often, of course, people automating the generation of test cases, test design, using Gen AI, using model-based testing, and coming up with a whole list of tests. And test environments. So again, there are numerous test environment management tools out there, test environment implementation tools out there. Again, we can use AI to optimize the usage, detect conflicts, do resource scheduling, etc., making sure you're getting the most efficient, effective use out of your test environments. At level 3, test organization. So probably this is, job descriptions, understanding what people's roles are, understanding career development. Probably one of the more difficult ones to see usage for AI. But there's always ways of analyzing team structures. There's always ways of looking at skills gaps. HR are using AI to do various things, such as taking on the right people in the first place. Although, as we saw with, I think, Vipul's presentation, sometimes HR can be subject to bias if it's using the wrong things. Test training program. Again, we said people need training in whatever they're doing within their testing careers, and they can get personalized learning using some of the AI tools that are out there at the moment. Non-functional testing. Again, it's easy to see how AI can be used there. It can be used to predict the bottlenecks. It can be used to simulate user behavior and assess the security risks, although, kind of ironically, AI can be a security risk in its own way. And finally, in level 3, peer reviews. I think we've all used AI to review documentation very quickly. We can do that now. There's no reason to stop doing that. But it can also analyze the review quality and suggest improvements to that. At level 4, test measurement. So this is, again, something where AI can really help. We are detecting trends and anomalies and correlations in test metrics. So if you're measuring data from individual projects across a large estate, utilizing some of the AI capability to crunch that data and look at trends, anomalies, etc., and report back on those is an ideal use in this situation. Product quality evaluation, again, I said, was about understanding what the product quality is as we go through. And one of the things we find here is that it's notoriously difficult to measure product quality in a quantitative way. So people try putting metrics together which use things like the number of defects and their severity and priority, use things like the number of test cases run and their relative priorities, etc., and try and translate that into a figure which gives you an overall product quality rating. It's very difficult. We see people implementing it in fiendishly complicated spreadsheets. Again, utilizing AI to crunch those numbers, come up with a quality scoring model in its own right would be a good way of doing that. Advanced reviews, again, can be difficult to understand how we're going to adapt the dynamic testing approach based on the early view of quality from reviews. But where AI can help there is in taking output from reviews and doing some logical manipulation of that data to identify where we are at that point. Level 5 is defect prevention. Defect prevention is important. We need to analyse the root cause. I think we spoke about the shift left philosophy earlier, and obviously analysing root cause, working out what that is, and applying the appropriate actions to stop them in the future is an important thing. AI, again, can help there with the analysis of those root causes and potentially recommending preventative actions. Quality control, as I said, is a lot of data. So you're really collecting a lot of data and understanding how you can use that data to make decisions which make your testing more efficient. We see people struggle with this all the time. It's a difficult process area to get right, and there are many, many ways in which it can be implemented which satisfy the TMMI model. Because you're basically crunching a lot of data, utilizing an AI tool to help you do that, and to do that in a way that you get a continuous dashboard approach to the quality, to the product quality quantitative measure, is a good one. And test process optimization, again, probably one of the ones that doesn't naturally spring to mind for this, but you can use AI to recommend process improvement based on some of the data you've got from historical outcomes. You can also use it to recommend tooling, which will be useful based on the data from what you're currently doing. So why does this matter? Well, I think it's important. I think one of the themes here has been AI is going to take everybody's job away. I don't think that's true either. I don't think it's going to take everybody's job away. I think we saw this when automation came in. What I remember when automation first started coming in and being widely used, people were saying, well, manual testing's dead. It's not dead. It's not going to die. But a lot of people moved to being automation engineers in quality. And I think what's going to happen is we're going to see a lot of AI engineers in quality. And I think that's a good thing, as long as people use it in the right way. AI copes better potentially with the complexity in the systems and environments that we're using. There is a lot of complexity now. And the demand to get to market quicker is just a fact of life now. So people want things done more quickly, but without compromising quality. And maybe some of these tools can help us there. So AI can be a catalyst for structured improvements, but with caveats. It's not a silver bullet. And again, looking back at what automation was sold as when we first started looking at automation, it was going to do everything. AI automation was, you press a button when you leave the office and everything's finished when you come back in the morning. It's not going to happen like that. I think this point's been made by other speakers, but be aware of data quality, be aware of bias. And interestingly, be aware of the skills gap. So again, when automation came in, using that same analogy, there were people who didn't have the skills to utilize automation. And there may be people out there now who don't really have the skills to utilize AI tools available. So make sure that you skill up the workforce, skill up your people appropriately to make sure that they can take advantage of AI. But over-reliance on AI can lead to the loss of the human understanding of systems. So if we just if we have a system that's designed, programmed, tested by AI, potentially you can get to the stage where no individual human in your organization actually understands what that system does. And I don't know if that's a good thing or a bad thing, but it feels slightly scary to me. But maybe that will become the norm. How do we get started? I think when we went through the list, there were a number of things that are more obviously suited to manipulation by AI tools. What we would always say is start with the data-rich areas. So start with things like defect analysis, start with things like defect reporting, start with things like environment management and test estimation. That's what AI is good at now, crunching numbers, really giving you some insights from the data that you can provide it. And data such as defects is less likely to introduce bias than some of the other types of data. When you're looking at the HR side of things, as we've seen earlier, there's a potential for bias in there. If it's defect data, if it's test environment data, if it's test estimation data from previous releases, it's much less likely to give you false positives or false results. And use AI to augment, not replace human judgment, especially in things like policy and strategy. As I said, policy is why we're doing testing, and that always needs to be related back to business objectives. AI may not have the knowledge to understand what those business objectives are or why they are the business objectives. And again, in strategy, most of us in this room could sit down and write a comprehensive test strategy from scratch, I would guess. But I wouldn't be able to write one for any of your organizations because I don't understand, what's important to you. I don't understand the context of your organization, and it's possible AI wouldn't either. So that's why, there isn't just one set of test strategies out there that you just pull down and everybody uses. It's got to be specific to that individual client. Automated test case generation is a really good thing to do, really easy. You can get started on that very quickly. But check and verify. I think trust and verify was the wording that Vipul used earlier. That's an important thing to do. We heard, I think, from Professor Dhaliwal earlier that so many AI implementations just fail for all kinds of reasons. One of those might be that they're not setting clear goals for your AI implementation. So don't just say, we need AI, let's get AI, let's go and do stuff. Actually understand from everything we've said earlier, which of those are important, which of those we want to really focus on, and go down that path with an open mind, but clearly focused on what your goals are for that AI implementation. And measure those goals. So when you run the pilot, measure the improvements, measure the benefits gained, perhaps measure maturity level using the TMMI model, and understand how AI has helped you to get to the point where you've got to. I came across this quote from a gentleman in America, at a university in America. I don't know whether some of the guys here may know him. by far the greatest danger of artificial intelligence is that people conclude too early that they understand it. So it's a rapidly evolving area. You need to understand that it may be capable of doing far more than you think it can do. It may not be actually good for what you think it's capable of doing. That's why you need to go into this with an open mind, carry out pilots, have that clear focus, and measure the benefits achieved or not. And that's it. Any questions?
That's right.
Yeah.
New generation are expecting everything to be delivered faster. Then that's why we need to leverage on AI more. But then you did mention that do not over-reliance on AI because of the trust issues.
Yeah.
So how can we actually balance this?
It's an interesting question, and I think the answer for me is that initially you can't, okay? But I think that trust and verify is about building that trust. So you get to the point where you run the model a few times, you understand that you're pretty confident now that it's giving correct answers, it's giving the right answer. At that point, you can let it get on with its own thing a little bit more and achieve those efficiency gains. But as with anything, in testing, it's risk management. So you need to be as sure as you can be based on the risk profile of what you're testing, that what you're getting are valid, sensible answers, and not hallucinations, not bias, not taking you down the wrong route. Thank you. No more? Thank you.